Okay, in this section, we're going to be doing a practice problem working with discrete probability distributions, looking at doing the mean and the standard deviation, and then going on to look at the issue of unusual events, such as we see here is number 16. So in this problem, we do number 15 through 17 on page 208, and then on the second video, you're going to do problem number 18. So first of all, here you have number 15. We have our x and our p of x, and we need to calculate our mean and our standard deviation. So we need to create a table and calculate those values. However, wait, we have missed a step. What step did we miss? We need to check our criteria to assess if this is indeed a discrete probability distribution before we go any further. So let's do that right now. Here are our criteria. So we have a numerical random variable x, and its values are associated with corresponding probabilities. And we can see we have that to the table on the right here. So we have a number of girls anywhere from 0 to 10. Each one has its own associated probability. So the next we need to look at is summing p of x so that it equals 1. So you need to pause the video for a moment and go through and sum up your p of x's and see if it sums to 1, or keep in mind also it could be 0.99999 or 1.00001 because of slight rounding changes when you round an exact probability to 3 values. So pause the video, add those up, and then turn the video back on to check your work. All right, if we do our sum, we know that our sum of p of x is indeed equal to 1, so we meet that criteria as well. Lastly, we need to make sure that each p of x is between 0 and 1. Remember, this is because the total amount of probability can only be between 0 and 1. 0 means it's not happening at all. 1 means it's happening absolutely. So each p of x must be somewhere between these two values. If you had a table, such as this on the right, and you had a p-value of, say, negative something, that's impossible. So that is not a discrete probability distribution. We can't calculate the formula for that. Or if it was having a probability for one of them of, say, 1.05, okay, that's also going too high. So here we can see that, yes, our table meets these 3 criteria, so we're ready to do our mean and standard deviation. So pause the video here, use the information that was just covered in the previous video to calculate your mean and standard deviation for this discrete probability distribution. When you've got that calculated, turn the video back on to check your work together. Okay, you should have gotten a mean of 5.0 and a standard deviation of 1.6. Okay, so our next step is to do number 16. Now, this is a different kind of problem. Here, we're asking about unusual events. So in order to answer this question, we need to first get our minimum and our maximum range. So here we have the formulas. Notice these are exactly the same as we've used before when we were doing frequency distributions. So our max is going to be our mean plus 2 times our standard deviation. And then our minimum is going to be our mean minus 2 times our standard deviations. So pause the video here, plug those numbers in and do your calculations, and then turn the video back on to check your answers. All right, you should have gotten 8.2 for our maximum value. That would be considered a usual value, and 1.8 is our minimum value for what would be considered a usual value. Okay, so when we're looking at this, we need to ask ourselves, for example, is the birth of 1 girl and 10 births, is this unusually low? Explain your answer. So when we're going to be looking at this, we want to be able to draw out 1.8 would be our minimum value, then we would have our mean at 5.0, and then we would have our maximum value at 8.2. I've given you kind of a diagram there at the bottom, and then the last thing is we plug into that is going to be our value that we're actually interested in this case, the number 1. So if you look at that, you can see that, in fact, 1 girl is outside the range of usual events, so it does count as unusually low. All right, now we're on to number 17, and here we need to pay attention to our language. So we're being asked 2 different types of questions here. They're both about the probability of 8 girls and 10 births, but we need to pay attention to how they're worded so we can make sure we're using the right formula. So if we're asked to calculate the probability of getting exactly that event, P of 8, then we're simply going to locate that over here in our chart on the right-hand side. And we only use the value for P of 8. So in this example, that would be 0.044. If we are asked to calculate a value at least as extreme, so we're calculating the probability of getting that event or any others at least that high or low, then we're going to be looking at the P of 8 or more. And this is a very different formula that we need to set up. So as we see here, our P of 8, if it's exactly P of 8, is 0.044. However, if we're looking at a value that's at least as extreme, then we're going to have P of 8 plus P of 9 plus P of 10. That is because if I have 9 girls, that also encompasses having 8 girls. So from a mathematical perspective, if I have 9 girls, I have 8 girls plus 1. So I have probability of 8 is incorporated into that probability of having 9. Same thing for P of 10. So P of 10 encompasses 8 girls plus 2 girls. So it still encompasses this P of 8. So this is where we have to apply a math rule to be able to understand how we're going to take our P of 8 or more. And again, we're looking at something that's asking something that's getting at least as extreme. So then we have our classical probability theory and our addition rule, as we have specified here. So you're going to take your value for P of 8, add to it your value for P of 9, and add to the value for P of 10. So pause the video for a moment, plug those into the formula and get your answer, and then turn the video back on and let's check that together. Okay, so you should have gotten, as you can see here, probability of 0.055 for our probability of 8 or more. Okay, so again, pay attention to the difference if we're asking for exactly P of 8 or if we're asking for something at least as extreme as a particular value. Now, let's move in and look at the next part of number 17. So the first question we have here is which probability is relevant for determining if 8 is an unusually high number of girls in 10 births? Should we use our P of exactly 8 at 0.044, or should we use our P of 8 or more at 0.055? Well, if we're calculating an unusually high or an unusually low outcome such as this, we're going to use the probability value that we're looking at as being an unusual outcome. We do not use the probability of the exact outcome. We do use the probability of that outcome and all others as extreme. So when you're being asked this type of question, you're going to want to use 0.055. Again, this is because if we have 8 girls, that is also encompassed. If I have 9, that also encompasses 8. And if I have 10, that also encompasses 8. So now we're ready for the last step for problem 17, which is question number D. Is 8 an unusually high number of girls in 10 births? So keeping in mind, now we're using our value of P of 8 or more. So remember this when you're looking at homework problems and exam problems. If it's asking is P, is something an unusually high number, they're actually asking you to use the probability of that value and all others as extreme. Okay, so be very careful about that when you're doing your calculations. All right, now we need to take that number and make a decision about its probability. So to answer this, we need to apply our rare event rule that we've been working with previously. So here again is a rare event rule. So if it's unusually high amount or an unusually low amount. So here we're looking at an unusually high amount. So we're going to have P of X or more. So here we have P of 8 or more. And that value has to be less than or equal to 0.05, okay, if we're going to say in terms of looking at the extreme of it. So here we have 0.055, that is our probability of 8 or more, and I've plugged it into the formula of less than equal to 0.05, asking the question, is this a true statement? This is not a true statement. So this is not an unusually high number of girls in 10 births. So having 8 or more girls out of 10 births is not an unusually high number of girls in 10 births. Okay? So this is, keep in mind, this is our 0.05 that we're working with here. And again, as I explained before, looking back earlier in the semester, 0.05 comes from our empirical rule on a normal distribution. So within 2 standard deviations, which remember for this one was 1.8 to 8.2, within those 2 values would encompass 95% of all of the possible events based on the probability. That leaves only 5% of the events not included within those 2 standard deviations. Okay? Now, when we have that particular situation, if we have 5%, if we convert a 5% to a decimal, we're going to get 0.05. So that is where our 0.05 comes from. It connects back with the 5% that lies outside the 2 standard deviations of our empirical rule and our normal distribution. Okay, so this concludes this tutorial. Next up is the last practice for this particular section, which is going to be problem number 18, which is a repeat of problem 17, just to help you get a little bit more practice with that.